All right, hey guys, this is section 210. This is the last section of chapter 2. And yesterday we did the review, which was kind of backwards, but that's because I was gone. So today we're going to chapter 10, or section 10. And then on Monday, we will review over chapter 2. Tuesday, we'll take a test.
Ew.
Yeah, and we'll finish review on Monday. We'll take a test on Tuesday. On Tuesday.
Are you gonna get whiteboards? Because I'm really bad at
Yes, we probably will.
Is next week Thanksgiving week or is it the week after?
The week after, next week. So that's kind of how this works. Section 210 is a short section, but you have to graph and do things. So that's kind of a little bit unpleasant, but it's short. So they have perpendiculars and distance, okay? And so let's talk about perpendicular lines. I'm going to draw two perpendicular lines up here, and they intersect each other, and they make a 90-degree angle when they intersect. That's the important part, okay? Those are perpendicular. And one thing that we know from algebra is that if I look at the slopes of these guys, the slope is the negative reciprocal. Okay, so like if one of them has a slope of 2/3, the other one is going to be negative 3/2. That type of thing, okay? That's stuff that we know from algebra. Now they're combining that with stuff that we need to know from geometry, and that is we're talking about distances and such, okay? So like the distance... Yeah, like the distance formula and that type of thing. So we're kind of combining those two, okay? So that's where, you know, like in section 2.8 the other day we had like equations of lines and such, and you were like, I like this section. This takes us back to algebra 2, but how does this have to do with geometry? Now they're kind of marrying the two together, and we're talking about distances and perpendiculars, okay? All right, so here's the deal. They have a little diagram going on here, and I'm going to take this diagram and I'm going to flip it just because it's easier to explain, and I'm going to draw it over here. So I'm going to draw the line flat, so he's like rotated around, and I'm going to draw my dot, which they label as C. I'm going to call him my little airplane, and that's what he looks like. Okay, so there's my line, and this is like, I'm going to call it sea level. Okay, so I have my airplane and I have sea level. Okay, so there's kind of what that looks like. I'm just taking this diagram over here and flipping it around. Okay, and we're going to talk about the distance that this airplane is up in the air. Do you know what a distance that distance is called? They have a name for it. They don't just call it the distance or the height.
Elevation?
Not quite. Elevation would be like the land or whatever in relationship to sea level, I think.
I don't know.
You're sitting in a plane and they're like, we have reached a blank of 13,000 feet or whatever, 32,000 feet, whatever. What? Altitude, that's what it is. So this is kind of like an altitude, okay? And when they tell you the altitude of how high you are in the plane, they don't measure, this is going to kind of seem like a stupid concept. Of course they don't do that. They don't measure this distance right here, like at an angle to the ground, right? They don't measure this distance at an angle to the ground. They measure it straight down to sea level at a perpendicular length, right? And they do that, and then they find the distance there, straight down underneath, and that's your altitude, or that's your distance, right? We don't measure it at an angle, and you're like, of course, why would we do that? That doesn't make any sense, right? That doesn't make any sense at all, like that we would do that. But when we talk about distances, we're talking about like the shortest distance, right? Like this would be the shortest distance. This is going to be a longer distance. The shortest distance is going to be that perpendicular distance, right? Okay. Now, this makes sense. Like that's obvious, right? That we would go straight down, okay? But let's say you're trying to find the distance between two like parallel lines like this, okay? Those two lines are parallel, all right? And I have a lot of people who, if like we have this dot on this parallel line, right? They are wanting to measure it like that. That's the distance between the two. But is that the shortest distance? No, the shortest distance would go like this way, right? Like thinking of this as a ladder going sideways, right? We would want to do that perpendicular. We would want to find that distance, okay? So be careful when you're doing this, and especially when they are at slants, that you're doing the distance that is perpendicular and not just like the straight down distance, okay? All right, so you can kind of see that down here in this section. They want us to use this line right here and use this point A, and they want us to just draw where the perpendicular would live, okay? And because this line is at a slant, okay, it's going to change things a little bit, but I have a lot of people that try to incorrectly like draw the line just straight down because they're like, oh, it's going straight down. Well, yeah, that would be if the line was completely horizontal, but because it's at a slant, it changes things, right? So straight down perpendicular would be like a line that probably looks like something like that, maybe, right? making a 90-degree angle that way. It's not completely straight down because your line is not completely horizontal, okay? And I just saw Angel just do it. She didn't realize maybe that she did it, but it's helpful. I can't rotate my paper on here, otherwise it'll screw up the board. But on your paper, make it so that you twist it so that he is completely horizontal, right? Like you're looking at it straight, and then it's helpful for you to see that it's straight down. Does that make sense? So if you rotate your paper a little bit, it will help you make that straight down, that altitude, or that perpendicular. Make sense? Good, good. Okay, so let's go on down below here. We only have 2 examples left. This is kind of short. They give us line L, and it's at the points -5, 3, and 4, -6. Okay? -5, 3, 4, -6, and this is the line L. This is what's given to us. What? Jalen's dying.
She goes, how did you even say it?
Sorry. She's dying. Oh boy. Oh boy.
Not feel like this. Well, stop dying.
Okay, so they give us line M, or line L, I mean. They call this line L. You can see that he's line L right there. And they give us those 2 points. And let's figure out what the slope is of that guy.
A number.
How much is it going down and over and down and over and down and over?
It's -1.
-1. He's going down 1 over 1, right? Okay. All right, then they give us point P. Point P is this guy right here, and that's all they give us. They technically don't even give us the line that point P lives on, right? Point P is at 2, 4, and we need to find the slope of that. We like make a line go through him, and his slope is going to be at 1. That's what Libby said, right? The negative reciprocal of -1 would be +1, right? Okay. And if we draw a line like up 1 over 1, up 1 over 1, up 1 over 1, where is he going to connect right here?
What? At 0, -2. Oh.
Other way, -2, 0, right? He touches that -2, 0 really nicely. He connects really nicely. And so what are we trying to find?
The distance between L and point 2, 4.
The distance between L and point P, right here. We're trying to find that distance, okay? Now, beforehand, they give us the lines, right? But a lot of people might, like if you're trying to do this, might try to find this distance, right? Because it's straight down, right? But that would be if the line was horizontal, right? This is not perpendicular to the line. So we're not finding that distance. We have to find this one. We're trying to find this distance here. And we do that by doing like the distance formula. Do you remember distance formula? Yeah. It's not too bad.
Not really.
Distance plus distance. So like this is the distance in the x directions, the distance in the y directions, right? Kind of like that.
One?
Yeah, this one. This is not too bad. Distance formula, finding the distance. It's kind of like finding the Pythagorean theorem, right?
That's
Yeah,
the way I write it out.
So if you want to look at this as like being a triangle here, right? You can do that as well, okay? So like in the x direction, you're going from -2 to +2. That is a unit of like 4. 4 in the x direction and 4 in the y direction, right? From 0 to 4. So it's 4 and 4. So you take 4 squared plus 4 squared and the square root of that. So 16 plus 16, square root of 32. And that is 5.7. If you do it on your calculator, 5.7 is what we came up with. So the distance between those is 5.7 units. Does that make sense? Perpendicular. You want to find the spot where they intersect and then go ahead and do your Pythagorean theorem stuff or the distance formula stuff. Okay, good? Happy with that?
Yeah.
All right, now on the back side, we have 2 lines that are parallel to each other, and we're trying to find the distance between those 2, okay? So I'm going to graph this. I'm sorry for not giving you a graph to begin with, but here's that. Okay, so we're going to graph these 2 lines here. I will give you graph paper for your homework assignment, but there's that, okay? So the first one, I'm going to graph this guy. We start at 1, put a dot, and we go up 2 over 1. Just do the best you can. Okay, up 2 over 1, down 2, left 1, something like that, right? There's that guy. Then the other one, we'd start at -3, 1, 2, 3, and we go up 2 over 1, and he looks like this. Same thing, but the other way, or but down lower, okay? So there's my 2 lines. I'll give you a second to do that.
No promises. This was surprisingly pretty.
Pretty even. Nice, very nice, very nice.
Say the same.
Very nice. Let's talk about the slopes of each one of those. They give it to you in the formula. They're the same. They're both 2. Okay. All right. So, all right. Given that that's a slope of 2, we did this morning, and what we're trying to do is we're trying to figure out how far apart those 2 lines are. okay? And Kyle said this morning, 4. I said,
What?
wrong, but I know how he got 4. Do you know how he got 4?
He added.
Look at this right here. This is a distance of 4, right? 1, 2, 3, 4. That's 4 units apart. But that's not perpendicular, right? Think of this as a ladder. So we can, I know. So we can write perpendicular lines like here, or here, or here, or here, or here. We can write them anywhere we want to, right? Perpendicular lines along there. But what we're going to do is we're going to pick some nice points, right? Like pick a nice point that we're already at. Like I see this nice point on 1 right here. And I want to draw a perpendicular through him, right? We're going to start with that 1, okay? So if my lines have a slope of 2 already, what does the slope of that perpendicular line need to be? Negative 1/2. Okay, so starting at that point, if I go down 1 and over 2, oh, look at that. Look at that. He lands really nicely on that point. Woo. On that point there, yeah? This is the point 2, 0, and this is the point 0, 1, right? Something like that. And then all we have to do is find that distance, like this length right here, how far apart that is, right? Okay, so you can do your distance formula or you can do the Pythagorean theorem, doesn't matter, it's the same thing, right? So I'm looking here and I'm looking at the x's, so how far apart is 0 and 2? 2, okay, and then if I look at the y's, 1 and 0 are 1 unit apart, okay? And then I do the square root of 4 plus 1. 2 squared is 4, 1 squared is 1. So that is the square root of 5, which is like something like 2.3, I think, or something like that. So they are 2.3 units apart. Yeah, not too bad, okay? So it's helpful to graph each one of these. I will give you some graph paper, but there's that. Yeah, that's all I have. Oh, let's talk. I'll talk through which problems I want you to do. Hold on, Junior. Hold on, Junior. Where? Oh, over here. Let me tell you what problems I want you to do. Jake.
So like if I look at them once, do we will I be able to know? Yeah. I was trying to figure out what you were talking about at first. Phrase, and then like oh my god, our ad class is gonna be so good.
Okay, practice side. People watching this video, practice side. Do 1, 2, 3. Practice side, circle these. Practice side, do 1, 2, 3. And 5, 7, 9, 11.
9/11.
Just the odds after that, okay? On the other side, 1, 2, 3, and
This is skills practice, right?
skills practice, 1, 2, 3, and just 5, 7, 9. You don't have to do 11, 13. So it's basically the odds, except you do 2 also, but you can skip 11 and 13, okay? All right, before we stop this video, I want to talk about like go to practice side number 3. This is what this looks like. They're wanting you to draw a perpendicular, or sketch a perpendicular from T to line UV.
Number 3.
And number 3.
Bro, what?
What? Yeah, exactly. From T to line UV, which is kind of, or VU, whatever. That's
Can you even do that?
odd, yes. But what happens? It's going to be outside, so you have to extend this guy, right? Like you have to extend this line out a little ways, okay? And then if you need to rotate your paper so that this line is on the bottom, go for it. Rotate your paper. I can't rotate my paper. But T, to make it perpendicular, I don't know, something like this. I'm trying to make it a 90-degree angle. I'm going to make it look like that. There's my 90-degree angle, okay? So sometimes you will have, when you're connecting these, you'll have to extend that line out and get him to be perpendicular. Again, rotate your paper so that you can get that figured out, okay? Now, not always will he be outside of the diagram. Like if you scroll over to number 2, you're going just from A to line DC. You can just go straight down and do the best you can for that guy, okay? All right, I'm going to stop the video. That's all I have for you. There you go.